Alright, 8th graders, lesson 69, direct variation. Recall that when two variables are proportional, the value of one variable can be found by multiplying by a constant factor. So we say y equals, and k is the variable, times x. So if k is 2, then if I did times 3, or if I did 2 times 4, or if I did 2 times 5, then y will be able to figure out 6, 8, and 10. So if we were to graph that, it would be a nice line going up by the same amount. So that's a direct variation. K here is called the constant of proportionality. It's constant. It doesn't change. So that could be a scale factor. It could be a unit rate, unit multiplier, some number that doesn't change. Your book shows you the example, like how many dollars you make an hour at your job, or if you're traveling your car and you set the cruise and it's a constant 60 miles per hour, something along those lines. Okay. Now with constants as well, we see something with a constant. If, let's see here again, y equals k times x. If one of the variables is a 0, the other must be a 0. So if I had, the constant was 2 and I multiplied it by 0, well, y is going to be 0. Okay? And the other rule is, again, as like on a graph, as the x changes, let's say x becomes a 1, then the y will change by the exact same amount. So that's what we're going to work on today. We're going to figure out, we'll either have to figure out k, what is the constant, or they're going to give us the constant and we got to figure out either x or y. So let's take a look at example 1. Which of the following is an example of direct variation? A taxi company charged $3 to start the ride, plus $2 per mile. B, the area of a square is the area of the length of its sides. And C, the perimeter of a square is 4 times the length of its side. Well, we would say A is not a direct variation because it doesn't go through 0, 0. So it doesn't go through the origin, because I would cross the y-axis at $3, because as soon as you step in the cab you got to pay $3. B, the area of the square is the length of its side. If I have to deal with an exponent, it's going to grow, the line is going to grow exponentially like that. So that's not going to be a constant. So we look at C. Again, if we do the ratios, 4 over 1, because a 1 and a 4 is in the first box, and then I get a 2 and an 8, so 8 over 2, that'll be 4, and then I get 12 over 3, that'll be 4, and a 16 over 4. And it goes through the origin, 0, 0, so I've got a nice line like this, and it goes through the origin. Then C would be the example of a direct variation. So I would say C would be the correct answer there. Alright, your book goes on to talk about independent and then dependent variables. Independent one is the one that changes. So like in the equation, dollars per hour. Let's say I'm making $12 per hour at my job and I'm going to work X hours, so I'll get paid Y. So the independent is the one that's changing X. How many hours I work? This week I worked 3. Last week I worked 8. This week I worked 4. So that's the independent. The dependent one is the one that's constant, that doesn't change, such as $12 per hour, or I'm constantly moving at 60 miles per hour. So remember those terms as well, independent and dependent. Alright, example 2, double day, doubled every number Eunice said. The table shows 4 numbers Eunice said and Doubleday's replies. Sketch a graph of all the numbers Eunice and Doubleday could say. Is the relationship of numbers, they say an example of direct variation, write an equation, and what is the constant. So let's first get a graph in here. Alright, here we've got a graph, and I get over 2 and up 4, and I've got a 1 up 2, and I've got a -1, -2, and I've got a -2, -4. So if I try to graph that here, not a perfect line, but it will do. That would be my graph, and it would. Then the next question is the relationship of numbers a direct variation? And I would say yes, it goes through the origin, although my line doesn't show that there. And we have a constant of proportionality, and that is 2. 4 divided by 2 is 2, 2 divided by 1 is 2, -2 divided by -1 is 2, and -4 divided by. So the constant, they asked that actually in the last question, what is the constant of proportionality? The constant is 2. Now they also want us to write an equation for the relationship. So I would say y equals, and now we have learned y equals mx, plus b. Now in this case the b is going to be 0. So that's why when I go back over here now, I'm going to be writing without the b. So the constant is a 2, and then you can put in the x. So that's what Eunice was. You said, I'm going to put in a 2, and Doubleday said, all right, it's a 4. Or Eunice said, okay, it's only a 1. Doubleday said it's a 2. So he was doubling each one, multiplying it by 2. Therefore, we get this graph over here. So we've got all the parts answered to example 2. Let's go on to example 3. Jared earns $12 an hour helping a painter. Create a table that shows his pay for 1, 2, 3, and 4 hours of work. Is Jared's pay for hours worked an example of direct variation? If so, what is the constant of proportionality? Go ahead and draw this here. Let's see, I only need 4. So 1, 2, 3, 4. And over here is his pay. So 1 hour he get $12. 2 hours you get $24. 3 hours you get $36. So this looks like a constant here. And if I divide 12 divided by 1, that's 12. And if I do 24 divided by 2, that is 12. And if I do 36 divided by 3, that's, so it looks like I've 48 divided by 4 is 12. So I've got a constant. And they ask, is Jared's pay for hours an example of direct variation? I'd say yes, because if he works 0 hours, he gets 0 pay. So that means I'm going, again, through the origin there, and I've got a constant. For every hour, he gets 12 more dollars. So yes, this is an example of direct variation. And what is the constant? The constant here would be $12. All right, that's it for today. You can get started on your lesson practice.